Hey, and welcome. Today, we're going to unlock a mathematical toolkit that, believe it or not, secretly governs pretty much everything, from baking the perfect cake to the actual laws of physics. We're talking about ratio and proportion, and trust me, by the end of this, you are going to see the world a little bit differently.
Okay, but first, let's start with a puzzle. Imagine you're reading by a lamp. If you move twice as far away, the light doesn't just get half as bright, it gets a whopping 4 times dimmer. So why on earth does that happen? Well, the answer lies in a secret key that we're going to find together. To find that key, we have to start with the very first tool in our kit, the ratio. At its heart, it's just a really simple but really powerful way of comparing things.
You can think of a ratio like a recipe's most basic instruction. It doesn't tell you the grams of the cups, it just tells you the relationship between the ingredients. Like for every 2 parts of flour, you need 3 parts of sugar. It's a pure comparison, and that's exactly why it doesn't need any units.
But there is one golden rule you've got to remember. You have to be comparing like with like. You can't just compare 50 centimeters to 2 meters. It doesn't work. First, you have to get them on the same page. So once we turn those 2 meters into 200 centimeters, boom, the true relationship of 1 to 4 becomes crystal clear.
All right, now that we've got the basic tool down, let's level up. We're going to see how to use ratios to share things out fairly and even how to link different ratios together.
So, when it comes to sharing with ratios, you'll pretty much always face one of 2 situations. Either you know the total amount you're splitting up, or you only know the difference between what people are getting. And knowing which problem you're dealing with, well, that's the absolute key to solving it.
So, let's put that to the test with a classic difference problem. Andy and Beth are sharing some money in a 3-to-5 ratio. We don't have a clue what the total is, but we do know that Beth gets £40 more than Andy. So, the question is, what was the total amount they shared?
Here's how we crack it. First, just look at the ratio. The difference between Beth's 5 parts and Andy's 3 parts is, well, it's 2 parts. Simple enough. And we know that 2-part difference is worth exactly £40. So if 2 parts equals £40, then 1 single part must be worth £20. That's our building block. Now all we have to do is find the total value of all 8 parts put together,
Which gives us a grand total of £160. See how that works? We worked backwards from the difference to find the total. That's the trick.
Now, what if you have 2 separate ratios that share something in common? Say, you know the ratio of apples to bananas, and then the ratio of bananas to cherries. To get the full picture, you need to connect those 2 chains. The trick is to make the shared link, in this case bananas, or y, the same number in both ratios. So here, we just scale them up so y becomes 12 in both. And just like that, we forged one single chain, revealing the complete relationship, 8 to 12 to 15.
Okay, so we've mastered static comparisons. Now it's time for the main event, understanding how things change together. It's time to finally find that secret key we've been looking for by unlocking the power of proportion.
Meet K, the constant of proportionality. This is it. This is our secret key. It's the magic number that perfectly defines how 2 quantities change in relation to each other. Once you find K for any relationship, you can predict any outcome. It's the absolute core of solving these more advanced problems.
Now think of this slide like a control panel. It's a translator. It takes the language of proportion, things like y is directly proportional to the square of x, and turns it into a real, usable equation that features our secret key, K. This is your reference guide for everything we're about to do.
So, let's put this toolkit to the test. Proportional relationships really come in 2 main flavors. You've got things that change in harmony, and you've got things that change in opposition. Let's dive into direct versus inverse relationships.
Direct proportion is all about harmony. As one thing goes up, the other goes up right along with it, right? More hours you work, more money you earn. Inverse proportion is the opposite. As one thing goes up, the other goes down. The faster you drive, the less time your journey takes. And the key difference is all about where our little k fits into the formula. Okay, let's try one. Here, this variable m is directly proportional not just to r, but to the square of r. We've got our starting point. When r is 5, m is 200. So, what's going to happen to m when r gets bumped up to 8?
The process is always the same, which is the great part. First, we translate the words into the right equation from our control panel. M equals K times R squared. Second, we use the numbers we know to find our secret key, K. So we plug in 200 for M and 5 for R. We solve it, and we find that K is 8. This is the breakthrough moment. We now have the master formula for this specific relationship. M equals 8R squared. With this, we can predict anything.
And when we plug in our new value of R equals 8, we find that M is 512. Wow, that's a massive jump from 200. That, right there, is the awesome power of a squared relationship.
We've done it. We've assembled our entire toolkit. We get ratios, and we've finally found the secret key of proportion. So now it's time to go all the way back to where we started and solve that mystery of the dimming light.
The solution to our puzzle is a fundamental law of physics. It's called the inverse square law. It states that the intensity of something like light is inversely proportional to the square of the distance. And this isn't just about light. This governs gravity, sound, even radiation. It's a core rule for how our universe is put together. All we have to do is apply our three-step method. 1. Set up the inverse square formula. 2. Plug in the values we know, an intensity of 800 at 2 meters, to find our secret key, K, which turns out to be 3200. Now we have the master formula for this light source. So for step 3, we just plug in our new distance of 4 meters to get the final answer.
And here it is, our answer, clear as day. The intensity just plummets from 800 all the way down to 200. Doubling the distance didn't have the light. It made it 4 times weaker because we're dividing by the distance squared. That is the incredible power of an inverse square relationship. So we found the secret key and we used it to make sense of the world. My question to you is this. Now that you know what to look for, where else are you going to see these powerful laws of proportion at play? From the gravity-holding planets and their orbits to the perfect mix of ingredients in your favorite recipe, once you start looking, you will see it absolutely everywhere.
Thank you so much for watching! And for more helpful videos, math and science videos, don't forget to like this video and subscribe to our channel. See you soon!